Warm-ups. What numbers 1 through 100 on a meter stick mean? Those traditionally refer to centimeters. The tick marks on a traditional metric meter stick are millimeters. To convert 270 centimeters, we remember our chart where part of it is this. There's other things on the left, but this is what we're looking at. To go from centi to the plain old unit of meters, we have to go to the left 2 spots. So I moved the decimal point 2 spots to be 2.7. Reviewing our algebra, when we add terms that have x's, the x does not change, only the numbers in front. And we can only add terms together that have the same letters. You cannot add 4x plus 3y to be 7xy or 7z. That just doesn't work. You can't add those together, but you can put the plain old numbers together. So we have the 10 for that. Spend a moment reading the rest of this page. Location and motion are measured in relation to some point called the origin. This can be put anywhere we want to, but often the situation will lead to an obvious logical choice. So the origin, just like in math class. Number 2, a frame of reference is made up of a system of the origin and arrows showing which way is positive. This is basically a number line that's used to solve the problem, just like in math class. Another name for this frame of reference is a coordinate system, and it's customary for the coordinate system to have positive values to the right of the origin or positive values going up. Again, just like you'd have in your traditional math class with your x and y axes on a graph. To the right is positive x's, upwards is positive y's, and negatives in the other directions. Okay, our first equation for physics. We have this triangle x. You've seen the triangle before in chemistry class. You saw equations with triangle T, triangle G, triangle H, triangle E. Those always mean change in. The change in temperature was triangle T. The change in energy was triangle E. Okay, now, the triangle is the Greek letter called delta. So I could read this as delta x equals x subscript f. The little f, a little bit lower, is called a subscript, or just simply sub x sub f. And then we have x sub I, subscript I, with a minus in between. Now what these things mean is the delta x is the displacement. And that's sort of like distance traveled. There's just a little bit difference between that and distance. X sub f is your final location. X sub I is the initial location, the starting point and the ending point. Okay, so the displacement is both distance and direction. Not only how far did it go, but did it go to the right or to the left, up or down. Final location is the ending spot, initial is the starting spot. Now, we can tell that numbers refer to these kind of x's if the numbers have the right kind of unit. If the numbers have units of meters, centimeters, millimeters, kilometers, inches, miles, yards, and all sorts of other things, furlongs if you are a horse racer, any of those would be an indication that those numbers go into the equations for the x's. Number 8, displacement has 2 parts, direction and magnitude. Things that have these 2 aspects, direction and magnitude, are called vectors, and there are a lot of different things, not just displacement, that's a vector. Magnitude is a fancy word for the size of the movement, how far the thing travels, the distance traveled. It's the digit part, not including the plus or the minus, but just the digits. The direction is shown by the sign. Motions up or to the right are shown by a positive. Displacements are shown as positive displacements. Motion left or downwards is shown by a negative displacement. The general procedure for all of your story problems will be to draw a picture, label the picture with known information and the frame of reference, convert any units if needed, change any negatives, state the desired variable. What variable are you looking for to get the answer? Number 5, find the raw equation that has the desired variable and where all else is known. There will commonly be numbers that are not used to solve the problem. So do not think that you have to use every number that's given. A lot of times I give you extra information and you have to determine which ones are needed and which ones are not. Substitute and do the algebra. Report your answer with the proper units. Okay, so we're going to use those steps in a few moments. But initially here, we're just going to look at using the equation. Okay, these are not considered story problems. We're just putting in the numbers and practicing the algebra. So we're given x sub I is 3 meters, x sub f is 18 meters. We want to find the delta x. So we have our equation, and we put in the 18 for the x sub f, bring down the minus, and then for the x sub I we have 3 meters. When we do that math, the the unit of meters does not change. Just like we had in the warm-up problem, where the x's did not change, the meters do not change. We just put the numbers, the 18 minus 3 is 15. Okay, next one. We're given x sub I. We're given the displacement delta x. We want to find the final location, x sub f. So we start off with our equation, and we put in the numbers as we know them. And we want to solve for x sub f. We want to get it by itself, so we want to get rid of a minus 5m. So we're going to add 5m to both sides, and we get 14m. 14 meters is our final location. Okay, now then, our first story problem, example number 3. A bicycle is located 3 miles on the right side of the river. It moves during the next 2 hours to be 6 miles on the left side of the river. What is the displacement? Okay, the first couple steps are to draw a picture and label it. So here's my picture. I have the river over here, the bicycle in 2 different spots, and then I label it with the known information. The initial location is 3 miles on the right side. The final location is 6 miles. The time in between those 2 locations is 2 hours. That's all the known information. And then we also include the frame of reference, the coordinate system. Since the location of the bicycle is indicated as 3 miles from the river, or 6 miles on the right side of the river, whoop, I just realized that I wrote something wrong. It says 6 miles on the left side of the river. It's not here. It's over here. And it's 2 hours still. We want to know the displacement from here to there. Okay. Where was I? Okay, we have the frame of reference. Since all of these locations are relative to the river, it makes sense for the origin to be located right there. Okay, what's the next thing? Convert units if needed. This is in meters. Miles. And this location, x sub f, is also in miles, so that's all okay. Those are called compatible units. Let's see what else. Number 4, state the desired variable. We did that right here. We're looking for the displacement delta x. Number 5, find the raw equations that have the desired variable and where all else is known. So we only have one equation to choose, so that's easy. Number 6, substitute in and do the algebra. The delta x is the unknown that we're looking for, so it stays a letter. X sub f needs to be -6 I had it as positive because it was written down here, I thought, on the right-hand side. But it turns out that it's on the left-hand side. And so that's the negative side of the origin. So I have to have that negative there. Okay, bring down the minus sign, and then the x sub I turns into the 3 miles. Okay, and then we do our algebra. And negative 6 minus 3 is going to be negative 9. And that's our answer with the units. Number 4, a bicycle is located 3 feet on the left side of the fence. It moves during the next 3 seconds to be 24 inches on the right side of the fence. What is the displacement? So step number 1 is to draw our picture. Step number 2 is to label it. And so let's look at this. Here we have a fence. We start off with the bike located on the left side, 3 feet. So x sub I is equal to 3 feet. And let's see here. It moves during the next 3 seconds. So the time between this is 3. It moves to be 24 inches on the right side. So here's x sub f, final location on the right side, 24 inches. What is the displacement? We're looking for the delta x. Okay, you notice here that I've crossed off the 24 that was given on the story problem. I replaced it with 2 feet because I want to have my units to be all the same kinds of compatible units. So the distances have to be measured in the same kind of distance unit. So 24 inches is the same thing as 2 feet, just from 12 inches is a foot. Okay, so that was steps number 1, draw a picture. Step 2, label the picture with known information and the frame of reference. Number 3, convert units. We did that. Now it says change any negatives for step 3. This is where I put in the negative here for the 3 feet. Since it's on the left side, the negative side of the coordinate system, I need to make that negative. Okay, number 5, find the raw equation. Okay, we only have one to choose from. And there's extra information. We don't need the 3 seconds. That's irrelevant. Substitute and do the algebra. So there's my substitutions. 2 feet for the x sub f. Bring down the minus. X sub I becomes a negative 3. Please note the double sign here. So the double sign makes a positive. 2 feet plus 3 feet is 5 feet. Read the mistake alert down there. Read that on your own. Refocus on today's purpose. I'm going to step away for just a second. Need to get a clean paper. Refocus on today's purpose. I will learn how to measure the distance and direction of an object's motion. We have now accomplished the purpose, and you could possibly do homework 8, but I find that people need more practice on deciphering these variables. And so I really want you to stick around here and let's go through this process. This is where people mess up the most. And so don't stop the video yet, but we have covered all the material that you need for homework 8. So we're going to do 3 things. We're going to figure out which of these numbers is x sub I, which of these numbers is x sub f, which of these numbers is delta x, and then do we need to turn any of them into negatives. Okay, so remember that x values all have units of length or distance. How far is a certain spot from the origin, or how far did the object move? And so this units of farness are things like meter, centimeter, millimeter, mile, inch, that kind of thing. If it does not have this kind of a unit, then it's not going to be an x, and we can skip it. Okay, an airplane flies to the right 600 kilometers. Its velocity varied from 80 miles per hour to 120 miles per hour. It started 200 kilometers on the left of the border, and after 360 minutes of flying, it ended up 400 kilometers on the right side of the border. Okay, let's cross off any of the numbers that are not x values because they do not have these kinds of units. This one and this one. That's speed or velocity. Here's a time. That's not an x value. Okay, now let's figure out which one is which. It flies to the right for 600 kilometers. This is how far it's moving. This is the displacement delta x. And it's going to the right, and in our coordinate system, that's a positive value. So we just leave it like that. We don't have to actually write down the plus mark, although you could. It started off 200 kilometers on the left side of the border. So this is a certain spot, 200 kilometers, and that's where it started, so that's going to be x sub I, the initial location. That's on the left of the border, and so that's going to be negative. So I'm going to put a little negative sign there. Let's see here. It ended up, so this is the final location, and that's on the right side of the border, so that's positive. I just leave it as it is. Number 7. 2 kilograms. Oh, you go ahead and read it. Pause the video, read it, scratch off the variables that are not x's. Okay, you should have paused it by now. This is not an x because it's mass. Let's see here. This is a time, so that's not an x value. This is a velocity. It's not an x value. Okay, now pause the video and figure out which one is the starting location, which is the final location, x sub f, and which one is the displacement, or how far it moves. Pause the video now. Okay, it says that the ball is this far above the counter, and it drops this distance and ends up this location from the counter. So this is the final location, x sub f. It ends up there. So that means that this must be the initial location. It drops a total of this. So this is how far it moves. This is the displacement, delta x. Now, these things are measured according to the counter, so it makes sense to make the counter the origin. And this is above the counter, so above the origin. On your graphing of math points, going above the origin is positive, so this will be a positive 30. Below the level of the counter is below the origin, and so this is going to be down on this side. That's the negative side. I'm going to put a little minus sign there. It's dropping 80 centimeters, so the movement is downwards. That's going to be a negative displacement. Number 8, 9, and 10. Pause the video and try to do number 8 on your own. Okay, you should have at this time paused the video, and you should have all sorts of marks here. The train stops at a station, so this is the x sub f. It's on the right side, so that's positive. It was a long 300 minutes. That's time. Ignore it. It began at a point 5 kilometers on the right side, so this began point is the initial point. It's the right side, so it's going to be positive. The distance traveled is the displacement, delta x. Now, it was 2,000 on the right. It ends up 5,000 meters or 5 kilometers on the right. So it's moving more and more. Whoop! It started off, I said it wrong. It started off, x sub I, at 5,000 meters, 5 kilometers. That's really far away. It ends up closer. So it is moving to the left. So this is going to be negative. Number 9. It takes 2 hours. Well, go ahead and read it yourself. Try to put in these variables and decide if they're positive or negative. At this time, you should have paused the video, and you should have all sorts of writings here. This should be scribbled out. It's a time. You scribble that out. It's a weight. Here, it moves at a steady speed from this spot. So this is the initial location, and it's on the left side of the origin. So that should be a negative 3. To a spot. So this is the final spot. This is x sub f. It's on the right-hand side, so that'll be a positive value. Find the snail's displacement. We're looking for the delta x, which we don't know at this time. Number 10, pause the video and try to do the same thing. Okay, at this time you should have paused the video with a whole bunch of writing here. It's dropped from a balcony that is 26, so this is the initial location, way up high above the ground. It's measured in relationship to the ground, so the ground is going to be our origin, and it's above, so this will be a positive value. Its initial velocity is 0. That's a velocity, ignore it. Acceleration, ignore. A time of 1.15 seconds, you can ignore that. It ends up hitting a teacher's head that is 2 yards. So this is the final location at the end of the falling. The final location, x sub f. It is still above the ground. So it's above the origin. The 2 yards is relative to the ground. So this is going to be positive. Find the displacement. We're looking for the delta x. All right, and that's the end of the notes.